Right, in this video, we're going to talk about reflections and how we can apply them to geometry. So typically a reflection, there's a couple different things that I think about with reflections. The first being like a reflection in the water or a reflection in a mirror, right? So both of these things reflect some kind of picture. It takes what's already there and then it gives you the exact same thing, but it's basically the opposite, right? So when you look into a mirror, in terms of size, right, the further away that you are from the mirror, the smaller things are going to look. But the closer that you get to the mirror, the larger that object in the mirror is. So the distance, right, the distance of how far away you are is going to be reflected in the mirror. So the size you don't have a super large image just because if you're super far away, you're not going to have a super large image in the mirror. That image is going to be the same size regardless of the distance that you are to the mirror. It's kind of confusing to think about, but what I'm trying to get at here is when we talk about reflections, the only thing that we're doing with these is we're flipping the shape across a line. And there's all sorts of things that we can do with reflections. We can flip it across like the line y equals 1, the line x equals -2. We could do like y equals 2x plus 1, all those sort of things. But we're only going to focus on two kinds of reflections, and that's going to be across the x-axis and the y-axis. But before we begin, okay, just like with translations, reflections have a special way that we can remember them, and that's with the F and the L in reflection. The FL stands for flip. Okay, so reflections, FL, the FL means flip. We're going to flip our shape across some kind of line. That's what we're doing with reflections. We're just flipping our shape across a line. So all of the points of our pre-image, all of the points of the original image are going to be the same distance from the line of reflection. Okay, now over here, this is the stuff that you need to put into your notebook. Okay, so this is not currently there. This is stuff that I've typed out. We're going to focus only on reflections across the X and the Y axis. Okay, so when we do these, we're thinking of the X and the Y axis as the mirror. So we're looking into the mirror and we're getting the same picture on the other side of the mirror. Okay, there's two different ways to do reflections. The first one is going to be counting the distance from each point to either the x-axis or the y-axis. And once we get there, we stop counting and we go backwards until we get back to 0. Okay, so this first example here tells us to reflect across the x-axis. So the first thing that I'm going to do is I'm going to identify where the x-axis is. Okay, so that's going to be right here. The reason that we need to do this is because we have to know what line we're counting towards. So from each one of these points from M, D, A, and W, I have to count the distance from the original point to the x-axis. Okay, so from this point A, okay, you can do this just like we did with the translations. You can do it as hops, or you can think of it as taking steps. But from point A to get to the x-axis, I just go down 1, 2, 3. Okay, so I went down 3 to get to the x-axis. Now from here, I stop counting, and I'm going to go from 3 back down to 0, but on the opposite side. So I go 1, or I go 3, here's 3, 2, 1, 0. So this point right here is going to be my A prime. I do the same thing for each one of the other ones. Okay. Now, what's cool is if I do W, I'm going to show you a little trick. I go 1, 2, 3, 4, 3, 2, 1, 0. So this is going to be my new W right here. Now, instead of counting from M all the way down to the line, one thing that I could do is I could say, okay, I know that the distance from W to M, I'll do this in a different color. The distance from W to M right here is just 1. So when I come down here, instead of counting from M all the way to the x-axis and then coming all the way back, I can just go to W and I can count 1 space and make my new M. Okay, it saves you a little bit of time. It's a little bit quicker, but it's still the exact same distance. So if you wanted to count to verify, you could. M is 1, 2, 3, 4, 5, and then 5, 4, 3, 2, 1, 0. Okay, you can do the same thing with this point D. From point M to point D, there's a total of 2 spaces in between them. So if I go straight down from D, okay, now there's a total of 2 spaces between M prime and D prime. And that completes my picture. So we shade it in. This is our new figure. Okay, so this is the easy way to do it by counting. The second way that we can determine where the points are going to be are by these 2 things right here. Now notice that there's 2 different things. We have one for the x-axis, one for the y-axis. Okay, if you're flipping across the x-axis, you're going to follow these 2 rules. That's what we're doing in this example. For the x-axis, the x value is not going to change. So when I reflect it across the x-axis, the x value does not change. So point M prime is going to be -1 for the x because the x value does not change. But the y value is going to be the opposite of what it originally was. So that's going to be -5. W prime, the x value does not change, but the y value is going to be the opposite. Okay, to verify this, you would start at the origin, the point 0, 0. If I go to W, that's 1 space, -1, and then down 1, 2, 3, 4. Okay, so this works every single time for the x-axis reflections. The x value stays the same, but the y value is going to be the opposite. So for point A, we have 4 and -3. For point D, or D prime, we have 1, -5. Now, the next example, we're going to take a look at what happens when we reflect across the y-axis. It's very similar to reflecting across the x-axis, except we're counting to the y-axis instead of the x. And when we do the x-axis, the y value is the one that does not change. The x value is going to be the opposite. Okay, so we're going to come down here to slide 10. And we're going to take a look at number 2. Now I'm going to do this not by drawing. I'm not going to draw first. I'm just going to use the points and come up with what my new coordinates are going to be. And then we'll go back, and the way that we'll verify this is by plotting the pictures. The reason that we're going to do it this way is because on the quizzes, you're not going to be able to draw unless you have your own graph paper at home. So I'm going to show you how to do this whenever they just give you the points and you can't graph, okay? So they want us to do this across the y-axis. The y value is not going to change. And the x value is opposite. Okay, so the y value does not change. X value is going to be the opposite. So for P, the y value is 2. For Q, the y value is 5. R, the y value is 3. And then S, the y value is 0. So these are going to be the y coordinate for P prime, Q prime, R prime, and S prime. Now for the x values, I have to flip. I'm just going to make each one of these x values the opposite of what it currently is. So opposite of 1 is -1. Opposite of 2 is -2. Opposite of 8 is -8. And the opposite of 7 is -7. So this right here would be my answer for the coordinates of each one of the new points. Now I'm going to go through and I'm going to plot these points. And in red here, I've got the y-axis lined out. So that way we know where we are reflecting our shape, okay? So this is the reflection mirror right here, the y-axis. The original shape, the p-value is at +1, +2. The q value is at +2, +5. There's q, here's p. R is at +8 for x, +3 for y. S is at +7 and 0 for the y. So this is my original shape. This is my pre-image. Now, if I was to count to the y-axis for each one of these, P is 1 unit away. So I go 1, and then from 1, I go to 0. So this point right here would be my P prime. For S, I'm 7 units away from the y-axis. 1, 2, 3, 4, 5, 6, 7. 6, 5, 4, 3, 2, 1, 0. So here is S prime. R is 8 units away. 1, 2, 3, 4, 5, 6, 7, 8. 7, 6, 5, 4, 3, 2, 1, 0. R prime, and then Q is 1, 2, 1, 0. Now we have Q prime. And we connect all these points together. Ideally, you would want to use a ruler to make sure that your lines are straight. Right here in blue is our new image. So we got the pre-image over here in red, and then the new image is in blue. Okay, and of course you can go through and verify all these points if you wanted to. So P prime should be at -1, +2. All right, P prime, -1, +2. So I start here at 0, 0, -1, +2. Q prime should be at -2, -1, -2, +5. 1, 2, 3, 4, 5. And I can do the same thing for P prime and S prime. Right, so the big thing about reflections, the thing that's going to make this section the easiest, is going to be the note that we put at the very beginning this thing just keeps moving on me. It's the note that we put at the very beginning of the reflections section. Okay, so if you can follow these rules right here, okay, either by counting, so you're either counting to the x-axis or to the y-axis. Once you're there, okay, once you're there, you stop counting and you count backwards until you get to 0. If you're reflecting across the x-axis, okay, this is for only the x-axis. The x value does not change. The y value becomes the opposite, and this is for the new coordinates. For the y-axis, the new coordinates, the y value does not change, but the x value is the opposite. Okay, so this is everything that you need to know for reflections. The quizzes is already assigned to you. So if you have any additional questions, please let me know and we can get those answered for you.